Are you actively interested in astronomy? If so, you've probably often come across the classic phrase that accompanies the paradox in the farm. But where are they all? It talks about hypothetical inhabitants of alien civilizations who have been unreasonably ignoring Earth's horizons for an unforgivably long time. In October 2017, the famous phrase partially lost its relevance because, based on data from the Panoramic Survey Telescope and Rapid Response System automated telescope system located on the summit of the shield volcano Mauna Kea in Hawaii, something disguised as an interstellar asteroid visited the vicinity of the solar system. But scientists didn't immediately give the object a ufological undertone. At first, Oumuamua was considered an ordinary comet, and weeks later it was reclassified as a hyperbolic asteroid. Notably, objects of this class had never been observed through Earth-based telescopes before. The hype about the visitor should have ended, but the wanderer unexpectedly surprised scientists with several major discoveries. Hubble, subscribe. The first thing astronomers noticed was Oumuamua's incredibly high speed. The object was moving under the influence of non-gravitational acceleration, which led specialists to make premature conclusions about the cometary nature of the celestial body. Oumuamua's speed, depending on its position in space, ranged from 26 to 88 kilometers per second. For comparison, Sedna moves at almost 2.6 kilometers per second, while the non-periodic Bowel comet travels at 3 kilometers per second. That is, such speed is not typical for small celestial bodies, which automatically raised a lot of questions. So what did the scientists have to deal with? Most likely, the asteroid's habitat is deep space, so the object is not gravitationally bound to any star. This means that we are dealing with an interstellar wanderer, the first to appear within the boundaries of the solar system. Moreover, given the uniqueness of the object, the data was immediately rechecked using a very large telescope installed on Chile's Cerro Paranal mountain, and it was fully confirmed, since no cometary coma was detected during the observations of the asteroid. Notably, in the catalog of space objects, Oumuamua was assigned a unique index, I. This stands for interstellar. Thus, the asteroid's second name is 1I 2017 U1. The first, more well-known name is taken from Hawaiian, referring to the place where the object was discovered, and means messenger from afar. How could such a small celestial body wander chaotically through the vastness of the universe without a permanent home? Astrophysicists believe that billions of years ago, Oumuamua was ejected by its parent star and has been lonely and wandering ever since. It is assumed that the catastrophic ejection may have been triggered by one of the stars in the constellation Carina. But is it really that straightforward? Isn't the mysterious visitor, for example, a planetary fragment, or even a man-made object? First, let's find out what the parameters of this strange guest are. According to observational data, including from William Herschel's telescope and the Hale Observatory, it was determined that the asteroid is presumably rocky, and its diameter is about 160 meters. But there is also other information. The object has a cigar shape, 30 meters wide and 180 meters long. Unfortunately, considering the small size of the asteroid, it is not possible to obtain more accurate data. But the fact that Oumuamua's shape is highly elongated is beyond doubt and causes confusion. How does the ellipsoid move? Surprisingly, it literally tumbles through space and behaves quite chaotically. By the way, spectral analysis of Oumuamua revealed some similarities with trans-Neptunian objects. Its surface emits the same uniform reddish color, but the question remains, why does the asteroid have such an unusual shape and rotate unevenly? Most likely this behavior was caused by some catastrophic event that happened in the distant past. Perhaps Oumuamua once collided with a planetoid or ended up at the epicenter of a stellar explosion. We are unlikely to ever know the truth. In any case, all the conclusions available at the moment have been published in the British scientific journal Nature. Do you want to know where the object was at the moment it was discovered? When Oumuamua was noticed by astronomers, it was at a distance of 30 million kilometers from Earth. But based on the object's speed indicators, scientists calculated that a month earlier, the ellipsoid had approached the Sun much closer than Mercury. And in January 2019, the interstellar rocky visitor crossed Saturn's orbit. Where is Oumuamua now? At the moment, the asteroid is approaching Pluto. Then it will gradually leave the embrace of the solar system, although this won't happen for another 23,000 years. Some astronomers, like Professor David Jewett of the University of Hawaii, believe the asteroid is unremarkable except for its shape. But can we trust such categorical conclusions? Let's turn to alternative hypotheses. The most popular opinion is that the object has an artificial origin. To find this out, there are even plans to send a space probe to land on the surface of the asteroid. It's hard to believe that such a project will be carried out. First, we should figure out how to colonize Mars and defeat the coronavirus. Nevertheless, there are considerations for creating the Starship laser sail engine, which would allow us to reach the target quickly. But some engineers are confident that this can be done using existing technologies if we use gravitational maneuvers and the Oberth effect. Meanwhile, a space probe using a light sail could accelerate too quickly and simply fly past Oumuamua. At the moment, a mission called Project Lyra is being developed. There are hopes that it will provide at least some information about the mysterious asteroid. And yet, what are the assumptions about the extraterrestrial origin of the interstellar object based on? Could it be that an alien spacecraft has finally visited the solar system? Did Robert Urich, who was the first to notice the strange asteroid, ever think that he was observing not just an ordinary rocky cigar, but a real alien shuttle? But enough questions. Let's try to examine the topic as thoroughly as possible. Given the object's high speed and unusual shape, it's reasonable to think it might be a reconnaissance probe or a lost spacecraft. Remember the unusual tumbling of Oumuamua. Such thoughts are expressed not by just anyone, but by Professor Avi Loeb of the Harvard-Smithsonian Center for Astrophysics. And as a member of the International Academy of Astronautics, he presents quite reasonable arguments. First of all, the astronomer insists that asteroids cannot have such a pronounced cylindrical shape. Just imagine a distinctly red elongated object that changes its brightness irregularly and moves quite unpredictably. Does that resemble any small celestial body known to modern science? It makes more sense to think this is a man-made object, marking the first proof of extraterrestrial intelligence. Jason Wright, a researcher at the University of Pennsylvania, holds a similar opinion. But the opponents of Loeb and Wright are relentless. They insist that Oumuamua was not originally cigar-shaped. It stretched out as it passed near some massive object, for example, a black hole. To prove this, a computer simulation was created that clearly demonstrates this process. And despite all this, there are persistent analogies with Arthur Clarke's novel, Rendezvous with Rama. According to the plot, a space patrol accidentally discovers a cylindrical object in the solar system, which was initially mistaken for an asteroid. Besides, why haven't we observed a similar object during all the years of astronomical research? If its exotic silhouette can be explained so simply, then there should be many more such small celestial bodies. The second question that Avraham Loeb asked the public is, why is Oumuamua so bright? A rocky, dusty object cannot reflect light as actively as the strange visitor that came to us. Doesn't this mean that its surface is metallic? And the last, most important argument of the university professor concerns the asteroid's self-acceleration. The fact is that the object's movement is not like the uniform flight of a cannonball. On the contrary, from time to time, it spontaneously accelerates. Is this an attempt to start the engines? Against this background, the feeble attempts of opponents to attribute this phenomenon to reactive gas and dust jets periodically shooting out from the heating surface of the asteroid look ridiculous and unconvincing. Then why, when passing by the sun, did Oumuamua not behave like a comet and not release a single such jet? In general, the question of the true status of the interstellar object remains open to this day, which leaves room for pseudoscientific speculation. Meanwhile, the asteroid, or if you prefer the spacecraft, is rapidly leaving the solar system, having first puzzled the inhabitants of Earth. Be honest, have you often dreamed of traveling in a time machine? And really, why not roll back to past centuries or even admire the Earth at the dawn of time? If you don't have a time capsule yet, then the Hubble channel will gladly take on that role for you. By the way, after a certain period of time, our own planet will become a kind of portal, transporting humanity into the past. Attention, the process has already begun. The thing is, in about 300 million years, the outlines of the continents will return to their original state and merge into the titanic continent of Pangaea, covering almost 150 million square kilometers. What does the modern picture of the world, which we are all used to, look like? There are currently 6 continents: North America, South America, Africa, Eurasia, Australia, and Antarctica. But it wasn't always like that. Geophysicists are sure that during the Earth's existence, several supercontinents formed on its surface, including Kenorland, which appeared almost 3 billion years ago, the Paleoproterozoic Nuna, and the Precambrian Rodinia. But sometimes they merged into true monsters, supercontinents, the most famous of which is considered to be Pangaea. Supercontinents were distinguished by their incredible size, as they contained almost all of the Earth's continental crust. Thus, Pangaea was monstrously huge, and it was washed by the truly hellish Panthalassa Ocean. Millions of years passed, and gradually the geography of the world changed, becoming the one we are familiar with today. Pangaea split into Gondwana and Laurasia, and later divided into 6 different continents. But by analogy with the universe, which according to some theories is destined to return to the point of singularity, the supercontinent will be reborn in about 250 million years, absorbing all the existing continents. What dangers do such radical metamorphoses pose to humanity? It turns out that after the redistribution of the continents, Earth will become an extremely uncomfortable place to live. To begin with, here are some scientific facts to support this. Scientists have long discovered that continents do not stay in one place, but are constantly drifting. Short-term shifts, of course, are small, up to 7 centimeters per year. That's about the same speed as human fingernails grow. But gradually, all of this will lead to the merging of fragments of the Earth's crust into a supercontinent, which geologists have already named Pangaea Ultima. It also has other names: Neopangaea, Pangaea Proxima, or Pangaea II. We'll explain where this linguistic confusion came from a little later, but the essence remains the same. In 250 to 300 million years, everything will change drastically. Back in 1974, John Tuza Wilson, a Canadian geophysicist, suggested that the formation of supercontinents follows a certain cycle. This means that they appear once every 200 to 600 million years. 13 years later, American geologist Christopher Scotese supported this theory and even gave the future supercontinent a name: Pangaea Ultima, the last Pangaea. But later, he realized that he had been too hasty, since it's unlikely that this conglomerate will be the final one, so he changed the name to Pangaea Proxima, meaning the next Pangaea. It's worth noting that both names have caught on well in the scientific community and are equally popular. How will the transformation process begin? Most likely, it will start with the formation of the supercontinent Amazia, which will appear in about 50 million years, with its center located at the North Pole. Another 200 million years later, North America will literally flip upside down, so frosty Alaska will turn into hot, humid subtropics. The same thing will happen to the harsh taiga expanses of Siberia. Meanwhile, Great Britain will move right up to the Arctic. Seas will disappear, including the Mediterranean, and in their place, mountain ranges will form. peculiar scars outlining the lines where continents join. What is the highest mountain on Earth today? Even school children know that. Its name is Everest, or Chomolungma, and its height reaches almost 9 kilometers. But that's far from the limit, because on the expanses of Panea Proxima, the peaks will be much larger, although of course they are unlikely to reach the size of the 26-kilometer Martian Olympus. An inland sea of considerable size will spread in the center of Pangaea, so people will no longer have to choose between the Aegean, Ionian, or Dead Sea. Apart from the ocean, only this huge body of water will be available. Don't think that these vast areas will be densely populated by cheerful natives. For the most part, the supercontinent will be covered by lifeless, impassable deserts, and its edges will be adorned with a necklace of mountain ranges. The climate will also change beyond recognition. The inhabitants of Pangaea Proxima will suffer from constant earthquakes, volcanic eruptions, and tsunamis of incredible power. But the most terrifying threat will be the hyperstorm. This cyclone, unknown to modern humanity, is currently considered hypothetical, but on the future supercontinent, the hyperstorm will become an everyday reality. What are the causes of this deadly atmospheric phenomenon? An unimaginable tropical cyclone can form when the temperature of the world's oceans rises to 50 degrees, which is higher than has ever been recorded on Earth. Such conditions are triggered by excessive volcanic or tectonic activity on the planet, the impact of a large asteroid, or significant planetary scale warming. Some scientists link dinosaur extinction to hypercanes. They say that after the comet struck, a series of monstrous tornadoes swept across the Earth with wind speeds reaching 800 kilometers per hour. The scariest thing is that modern hurricanes have a scale that defines the limits of destructive wind power, but a hypercane can grow infinitely. For it, there's nothing stopping it from expanding to the size of North America and creating tidal waves up to 20 meters high. Moreover, such winds are even capable of destroying the planet's ozone layer. But that's not all the surprises awaiting people who will live on Earth in 250 to 300 million years, if the planet doesn't cease to exist earlier for some reason. Against the backdrop of constant destruction caused by almost uncontrollable natural disasters, wars and pandemics will occur more and more often, and hunger will become a persistent problem, hanging over humanity like the sword of Damocles. People simply won't have time to lead a normal, productive life because they'll constantly have to fight just to survive. And it gets worse. Global desertification of soils will lead to a significant reduction in the number of plant and animal species, and the extinction of many species. Climate zones will be redistributed chaotically. Do you still associate Africa with unbearable heat? Then we have good news. On the supercontinent Neo-Pangaea, everything will be completely different. The territories of countries like Algeria, Libya, or Morocco will be covered by freezing cold. But the land of France, Iosif, and Antarctica could very well become a paradise, where agencies will sell tours at sky-high prices. That's why the phrase from the famous Soviet comedy about a resort trip to Magadan will no longer seem funny. But are there any advantages to living on such a vast continent? For example, how do people organize a transportation system over such large areas? Perhaps by that time, Elon Musk's Hyperloop will be crisscrossing the planet. However, the high-speed train of the future will have to go deep underground, because the menacing hyperganas are literally capable of ripping the Burj Khalifa out by its roots, not to mention any kind of vacuum tunnel. In short, the appearance of cities and countries will change beyond recognition. There will be a reassessment of values, priorities will shift, and geopolitics will reach a new level. After all, countries will become much closer to each other, gaining new neighbors. For example, to get from Russia to the United States of America, you won't have to cross the Atlantic Ocean because it will disappear from the map, and its place will be taken by a body of water of incredible size, where all the seas and oceans will merge. It would seem that its waters should turn into a real paradise filled with exotic sea creatures and luxurious plants. But even here, people of the future will be disappointed, because due to the appearance of a supercontinent covered with dead deserts, there will be less oxygen on the planet, which means ocean dwellers will also have to conserve it. Tell me honestly, would you want to live in this wonderful new world? That's a debatable question, especially if you take into account the scale of cataclysms that humanity has never faced before. Is it possible to stop the process of continental drift and prevent the likelihood of Pangaea Proxima forming? Unfortunately, at this stage, that's impossible, although science is constantly advancing, and maybe one of you will come up with a way to do it. After all, we have the prospect of building a colony on Mars. What if in 300 million years, humanity moves to the red planet with their suitcases, and Earth turns into a reservation for outcasts? However, we've gone too far, but there's still time to realize the problem and try to solve it. For now, the whole Earth, this is exactly how the word Pangaea translates, hasn't yet merged into a single stone lump swept by deadly hyperhurricanes. What does space sound like? And does it make any sound at all? Science fiction rarely goes into detailed descriptions of how sound travels in the depths of space. The same can't be said about world cinema. We all remember the loud boom when the Death Star was destroyed in the most epic movie saga, Star Wars, by George Lucas. And of course, we all had doubts about whether it should really sound like that. Perhaps Ridley Scott explained the propagation of sound in space best when he came up with the slogan for his sci-fi horror film Alien. In space, no one can hear you scream. The slogan really seems very true, not only because of the vast distances between objects in space, but also because of the very way sound travels. What important things can we learn from the basics? Sound is a special type of vibration in different mediums and bodies, for example, through particles of air, liquid, or solid objects. The so-called longitudinal wave. It exists in various forms, but we most commonly know it as a longitudinal wave in gases. Sound travels faster in light gases and slower in heavy ones. Remember the jokes with helium balloons, how you make your voice pitch much higher. This is a great example of the effect of light gases on the propagation of sound. Among other things, sound is capable of traveling through almost all possible physical mediums. You can hear your neighbor through the wall or a diver deep in the water. The quality of sound transmission will be different, but thanks to certain devices, we can easily detect these sounds. Sometimes the naked ear is enough. So what's the principle? Simply put, to transmit sound, you need the building blocks of the universe, molecules. Sound travels through waves, and a wave can't move without molecules. Space is silent because it's almost empty. Its density is only about 10 atoms per cubic meter, while the density of our atmosphere is roughly 10 septillion atoms. In other words, a certain density of matter is needed to transmit sound. If at this point in the history of the universe, the vacuum is filled with very few molecules, billions of years ago, the situation was different. Shortly after the Big Bang, the entire universe was a ball of hot plasma, dense enough for sound to travel through it. The shock waves of the universe's formation shook space itself, creating a cosmic hum. Would we have been able to hear it if we had somehow fantastically found ourselves there? Most likely no. This hum resonated at such low frequencies that the human ear simply wouldn't have been able to hear it. Once upon a time, space was filled with sound, but now there is almost complete silence. However, that's no reason to be sad. We should thank the properties of the vacuum. For what? Just imagine if sound could travel through space, we would be constantly tormented by the insane roar coming from our fiery star, the sun. Craig DeForest, a heliophysicist, believes that the loudest object in our star system could very well be the sun. It really could turn out to be incredibly loud. After all, inside our star there is a process of endless swirling of hot plasma. Nuclear reactions make our star blaze. Set in motion massive convective cells of hot gas, rising and crashing down across the entire surface of the sun. According to preliminary calculations, each of these cells is capable of emitting from 100 to 300 watts of sound energy per square meter. To better imagine the power of this sound, picture that it's about as loud as the sound produced by a police siren. After some simple calculations, considering that the surface area of our star is about 10,000 times greater than that of Earth, all you have to do is imagine the surfaces of 10,000 planets the size of our Earth are filled with police sirens blaring at full volume. It's hard to imagine how humanity could survive that terrible noise. Fortunately for us, we're protected by the void of space, but at the same time we live in a world of incredible sound diversity. We hear birds singing outside the window, the traffic of big cities, and the splash of waves. The earth is filled with sounds. It feels like our world is the only island of life and sound. But is that really the case? I suggest we use our imagination and take a journey through the planets of the solar system. Let's imagine that we can hear what's happening in these distant yet close worlds. Where can we begin our sonic odyssey? Of course, with the neighbor closest to the noisy sun, Mercury. On the surface of Mercury, there's practically a vacuum, which means there shouldn't be any sounds at all. However, there are some. Not in the atmosphere, but possibly in the rock. Cooling down is an early stage in the ordinary development of planets. Mercury is also going through this. During this time, the volume of the planet shrank, and its shell, which consists of rock that cooled and somehow solidified earlier than the core, had to contract. It was this that triggered the cracking of Mercury's surface layer and caused one part of the cracks to slip over another. This created a kind of scale where one layer of rock was pushed over another. So the past of Mercury is connected with the sounds that accompany the tremors. A lander equipped with a seismometer could find out if such tremors exist on Mercury to this day. The next stop is Venus. Because of its very dense atmosphere, much denser than Earth's, the sounds are very similar to those we can hear underwater. Imagine that you find yourself in a thick jelly with a temperature of about 480 degrees Celsius. In the early 80s, the Soviet lander Venera 14 successfully landed on the surface of the planet. During its hour of life on the planet's surface, it recorded the howling of Venusian winds. In addition, observations of Venus have shown us that flashes of lightning are often seen in its dense atmosphere. And do you know what that means? It turns out that we would be able to hear the rumble of thunder. What about the red planet? The sound on Mars is different from that on Venus in the opposite way. because its atmosphere is very thin compared to Earth's, meaning it has far fewer molecules. Most interestingly, we know this not from theory. Mars is number one for almost all scientific expeditions from Earth. There are 8 artificial satellites from different countries operating in orbit around Mars, and on the surface, 3 American robotic stations and 1 Chinese station are moving around. And it was only in 2021, National Aeronautics and Space Administration published on Twitter an audio recording that was captured using the Perseverance rover. You can hear a faint static crackle and a loud hum, which is presumably caused by strong gusts of Martian wind. But now, with the power of our imagination, we find ourselves in the middle of the Martian desert. What do we hear? Actually, we won't hear a wide range of sounds. Distant gusts of wind, the dry crackle of sand hitting the spacesuit, and the muffled crunch of the ground underfoot. The main factor affecting sound propagation is the composition of the air. The atmosphere is almost entirely made up of carbon dioxide, which absorbs high frequencies. Any sound in such an atmosphere becomes more muffled. Our journey takes us to ever more distant frontiers of the solar system, onward to Jupiter and beyond. We all know that Jupiter doesn't have a solid surface. The entire planet is made up of gases, which become denser closer to the center of the planet, eventually becoming liquid at some point. All these visible, beautiful swirls are caused by differences in temperature and pressure in the various layers of the gas giant. What about sound? Well, just like on Venus, we can observe flashes of lightning, which also means there are claps of thunder. Saturn, Uranus, and Neptune, like Jupiter, are mostly made up of hydrogen and helium. These 2 gases are lighter than air. The pitch of sound in them would be higher. But the different layers of the atmospheres of different planets each change the properties of sound in their own way. Saturn's moon, Titan, is the only one known to us on Earth with a real atmosphere. It's even thicker than ours, made up of methane and nitrogen, and it's very cold. And just imagine, on Titan it rains methane. In fact, scientists have concluded that Titan is an extremely flammable world. Fortunately, there is no oxygen on Titan, without which combustion is impossible. Otherwise, the planet would have exploded a long time ago. In the year 2005, the Huygens probe made an audio recording while descending to the surface through the thick atmosphere. Just imagine, if you were on the surface of this distant moon, you could hear an almost earthly gurgling and dripping. But this sound would not come from the familiar lakes and rivers we know, but from entire methane waterfalls. Outer space is mostly a vast desert where there is no medium for sound to travel. Undoubtedly, this is absolutely true, but the power of the human mind and imagination often recognizes no barriers. Vanda Dias-Merced, a scientist and astrophysicist at the South African Astronomical Observatory, is hopelessly in love with studying distant gamma-ray bursts. After a terrible tragedy that happened to Vanda when she was 20, she lost her sight. She had only one chance to continue working in the scientific world, to adapt, to hear the sound of the cosmos. I must say, she handled this task just brilliantly. Vanda and her colleagues developed a method. It interacts with absolute statistical information and transforms it into small-wave digital compositions. For example, those that depend on oscillation intensity and the object's size. The analog will also change its sound. Does this interesting technique have a name? Yes, this is sonification, the transformation of other information into a sequence of audio signals. But as we come to the end of the video, we already know that these sounds are by no means the only music of the cosmos. There must be many more real sounds out there, not just those synthesized by the system's algorithms. Yes, they seem to exist on tiny islands and vast oceans of silent vacuum, but the universe is not mute. It speaks to us, and we, in turn, must listen to it, using all the power of our mind and imagination. This was the Hubble channel, and we hope you enjoyed our video. Don't go far. There will be much more interesting content waiting for you soon. Talk to you soon. Check out the screenshots on the screen. These are YouTube statistics. What do they mean? Notice that right now, 57% of this channel's viewers are watching without subscribing. This is the true essence of my message to you. Therefore, so you don't miss out on Cubbo because of your subscription status, all you need to do is click on this red button, which looks like this and is located below this video. The law of the universe is simple, remember that. After all, every one of your subscriptions is very important to me. The more viewers there are, the more often they watch and hit the like button, the faster a new mega exciting video comes out. Talk to you soon.